Okay, so last video. Find a complete solution for the Cauchy-Euler equation on the interval from 0 to infinity. Alright, so Cauchy-Euler, that's a 2. T squared, that's a 1. That's a 0. That's what it looks like. And it's a function of just t over here. So, what do we say? A t squared y double prime plus b t y prime plus cy equals 0. Oh. Well, use an auxiliary equation. B minus A is the trick to all of this. He showed like how he came up with all this, but it's like it's much quicker to just know these shortcuts. So again, we're gonna have 3 cases for our auxiliary. We're gonna have 2 real roots. This is what our solution is gonna look like. So now it's not e to the r t, right? It's c t to the r1, c1 t to the r1 plus c2 t to the r2. We get a double root, c1 t to the r plus c2 t to the r times the natural log of t. And we got a complex root, it's t to the alpha, c1 cosine beta ln t plus c2 sine beta ln t. So that's the thing you got to remember. Remember that, Mark. Okay. So let's keep going. So back to the question. Here's our equation. Let's find our auxiliary stuff. So A in this case is 1, B is 4, C is 2. So A r squared plus B minus AR plus C equals 0. I don't do this every time I do it. It was just the first time, the first time it's good to show an example. So r squared plus 4 minus 1, right? B minus A. R plus 2, which is C, equals 0. Go ahead and solve for our roots. Okay, we got 2 real ones, so that's what our solution is going to look like. That's our general solution. So y1 is t to the minus 1 and y2 is t to the minus 2. Okay, so now use variation of parameters to find a particular solution, yp of the star equation. Be careful on rewriting star in standard form. What is standard form, you ask? Okay, well, standard form is this. You can't have any coefficients in front of this, so we divided by t squared on all this. Now, I'm computing the wrong skein ahead of time because I had y1 and y2. y1, y2, minus 1, minus 2. Okay, so this times this minus this times this. So we get this. I made a mistake somewhere, and I don't know where, but I'm not going to like totally go through a fine-tooth comb with this. Anyway, so calculate your wrong skin because you're going to need it when you get this v1 shit, right? So it's v1 y2 g of t over the wrong skin. It's the negative integral. So what do we say y2 was? That's t to the minus 2, right? Cosine squared t times t to the minus 4. That was this. Oh. Did I say t to the minus 4? Oh, no, it's this. And y2 is t to the minus 4, right? Okay, yeah. Wait. What? Okay, that might be where I made my mistake. Hold on, let me see. y2, which is t to the minus 2. Okay, that's that. Okay, and this... Where is my standard form? Why is that to the minus 4? Okay, so that's my mistake there. Well, it didn't affect it because I just canceled it anyway. So okay, so we got cosine squared t, 1/2 1 plus cosine 2t. That's a trig identity you should never forget. Go ahead and integrate that. Get this. I have an x here for some reason. It's supposed to be a t. Okay, so yeah, okay. And then v2 is this shit. Wrong skin. Anyway, just keep going along with it. What did I say my wrong skin was? Minus t to the minus 4. I put that up top, I guess. Okay. And then, anyway, so we get this. I'm going to do a u sub just to compute this integral. I'm going to get this, v2. Again, like I said, I messed up with a negative sign. So I assume I have v2 and I assume I have v1. That's fine. v1, y1, v2, y2. We had y2, we had y1, we got v1, we got v2. Go ahead and get that. That's our particular solution. I messed up somewhere in here because I didn't get this answer, but I had to check the solutions, and this is what yp is supposed to be. So now the general solution for that is going to be y, which is the homogeneous, or whatever. It's this solution here. What do they call it? I have to look it up again. It's y sub c. It was in the previous question. Complementary solution. Okay. So complementary solution plus the particular solution, which is this. Beautiful. Find the solution to the initial value problem. Blech. Okay, that's Cauchy-Euler as well, I think. Okay, so anyway, let's go ahead, find our auxiliary. Same rules apply. A is 1, B is 5. So B minus A is going to be this. We get ourselves a double root, so there's our general solution. Okay. I don't know why I wrote... Oh, no. That was... Yeah, I had it in the general format. So then there's our actual one. And then I just said that y is this, right? Because this is the initial value problem, so you don't need to like go and compute a bunch of derivatives. I did, because I had the tendency to do that on the last one too. Anyway, but so I didn't need to compute the second one. I mean, look at that. That's okay. So y is this y1 equals minus 2. Plug in 1 here. Oh, ln of 1, that's 0. That's nice. C1 is minus 2. Y prime of 1 equals 1. So plug this shit in. Oh, look, ln of 1. That goes to 0. And I just went ahead and took C1 and... No, I didn't do that at all, did I? Okay, anyway, I just solved for C2. I got C2 and C1 here. So there's C1, C2... and this is our guy, because this is the initial value problem, so it goes ahead and finds this, and y equals y of 1 and 1. Those ones are allowed, because if there was zeros in here, that'd be bad, right? I'd be dividing by 0 at some point when I divide by this t squared, right? So oh, actually this is exactly the same thing. So there's 0, you can't divide by 0. It's pretty much frowned upon. Okay, find the general solution for each of the homogeneous equations. You got that. So here's our auxiliary, b minus a, again. Okay, they're real. They're real. So there we go. We got our general. It just wanted the general? Yeah, okay, sweet. So this one, here's our auxiliary. We got a double root. Ooh, there's our general. And lastly, we have our reduction of order. What is this? So let's say we were given y1 as a non-zero solution of this. So we can find y2 by doing this. I wasted a whole bunch of time because I didn't notice this negative sign in the formula that I copied down. So make sure you don't forget that. That's why I highlighted here and highlighted here. So, because I was getting completely different answers because I didn't have... anyway, you'll see in a minute. So y1 we said was secant t. And then here's our differential equation. Here's the interval that's okay on, because you're not going to include those infinities, because we got like some tans in here, right? So you can't. It doesn't make sense to evaluate it at that. So it's in a region where tan's like defined, right? Okay, so, and secant, I guess, for that matter. I don't have those graphs memorized, but I know tans more or less. Y2, y1. Okay, the integral p t dt. So it's negative, right? And I said p of t was negative. So when I did this initially, I had a negative sign floating out here. So I didn't get this quick, dirty thing here, because then I'd have 1 over secant t. Well, what's that? Well, that's cosine. So then I had cosine here, and everything was ugh, right? So anyway, so y1, which is secant t, this guy, e to the ln secant t, which is just secant t, right? So that's that, divided by y1 squared, which is secant squared t. So now I get boom, boom, and then it's cosine because it's 1 over secant, and then you integrate that, you're going to get sine t, and then that's sine t over cosine t, so y2 equals tan t. So good luck, everybody, on the midterm. So that's every question. I did this in the last 2 days. I did it last night and tonight. And what time is it? 20 after 12. So I'm done studying. I got this video. I'll watch it a couple more times before I go and write the actual midterm. But until then, I'm not touching any more DE. Got too much else to do. So good luck.